Hello class, it's Mr. Ng, and I have a video here to help you manage all of your data from your magnesium oxide lab in Google Sheets. So I've done a lot of things here already. I already have an outline of my data set. This should look a lot like your table that you filled your lab notebook with. And here I have my raw data already filled in. So before I go too far, I want to format my table just a little bit. So I'm going to highlight this whole bit. And I like pressing this button, give me some borders. That way, when I copy and paste it over to my docs, it'll look a little bit nicer. I also like having a filled in color up here, just so it looks nicer. There you go. Blue and gold. Go Saints. So let's go through the various formulas. So here, for the mass of the magnesium, this is just the difference between the mass of the crucible with the magnesium minus the crucible, right? This is the little cup with a piece of metal in it. This is the weight of the cup. If you subtract the weight of the cup with the metal, if you subtract the cup from the cup with the metal, you just end up with the metal. So here, I'm just going to do, this is equal to this minus that. And there you go. I got my difference, and then I could drag it over. To drag it over, I click on the box. I look for this little blue corner here. This little blue dot shows up. I'm going to hover over it until my cursor turns into a cross. Not an arrow, not a hand, but a little cross. And then I could just drag this sucker over. And there we go. I did the math 3 times over, and it's way faster. For my experimental mass of the magnesium oxide, the MgO is the ash. Again, it's just a little bit of subtracting. This time it's the cup, the crucible with the MgO minus the crucible. So here, this is equal to this one, B5, minus this one, the crucible. And again, I have my answer. And again, I could just kind of drag it across by holding onto that little blue dot. Good. The formulas that are a little bit trickier are the theoretical mass. So let me walk you through the logic of the theoretical mass. So we're really lucky in this lab, well, not lucky, but it's very convenient that in this lab, it's a 1-to-1 ratio between magnesium and magnesium oxide. So we could simplify the math a little by just looking at the molar masses. Obviously, the molar mass of magnesium is 24.305, right? That's what it says up here. But for the magnesium oxide, for MgO, right, this is the magnesium. For MgO, it'll be the sum of these two. It'll be both the magnesium plus the oxygen, so that's going to equal to 24.305 plus 15.999. So the mass of the MgO is 40.3 versus 24.3. So our magnesium, this guy here, should grow by 40 divided by 24. Does that make sense? Right? If I had a piece of magnesium that's 0.1, let's put that right here, 0.1, then what should x be? Does that make sense? So if you want to just think about it in old school algebra, I would cross multiply 0.1 times 40.3 divided by 24. So we're going to go with that simple kind of math. So our theoretical is going to be equal to this guy, the mass of the little piece of metal, times, I'm going to do 40 divided by 24, or 40.3 divided by 24.305. And there you go. This is my theoretical. I'm going to drag it over. Boom. And then I don't like having all these digits, so I'm going to go up here and make sure that it's a number. Boom. Done. So this is what we should have gotten. I'll make this a different color so it stands out a little. All right, this is what we should have gotten. And then the experimental is what we actually got. The percent yield is equal to the experimental divided by the theoretical. It's equal to this box divided by this box. Okay? Oh, and of course, gotta multiply that by 100. So here, I'm gonna go back up into the formula here. Parentheses times 100. Done. And then I'll drag it across. Good. And then down here, I would do the percent. Oh, you know what? I would just turn this into a number, make it look nicer. And then down here for the percent yield, the percent yield is going to be the difference between 100 and this number. So I'm going to do equal to 100 minus this number. Awesome. So this team got 3% error, 24% error, and then 6% error. So they did a really good job, I think. So thanks a lot for watching. Feel free to pause the video and slowly go through these skills with sheets. I think it's really important in your future career in science. Bye-bye.